I'm Tim. This PCBSYNC.
In this video, we're focusing on a specific application, RF power amplifiers. We'll be looking at official technical documentation from Rogers and an open source RF network evaluation board to gain a better understanding of exactly why engineers evaluate RO4350B in power amplifiers and what specific issues need to be carefully examined and verified during the design process. Power amplifiers are quite sensitive to impedance matching, transmission loss, stability, and heat dissipation. The dielectric constant of R4350B is 3.48, with a tolerance of plus or minus 0.05. For transmission line design and matching networks, Rogers provides a design value of 3.66. At 10 GHz, its typical loss factor is 0.0037. A relatively stable decay helps control impedance and electrical length. A lower DF helps reduce energy loss in the dielectric. What you see on the screen is an open source RF network evaluation board. It's not a complete power amplifier production project, but the layout principles used here also apply to input matching, output matching, and balance networks in power amplifiers. You can see that there are multiple edge-mounted RF structures around the PCB, and in the middle there are two relatively symmetrical RF channels. The traces between the central components are very short, and the overall layout is kept as symmetrical as possible. This helps reduce differences in parasitic parameters and improves the consistency of amplitude and phase between the two signal paths. From the board edge interface to the central components, we can see that in the power amplifier, the connector pad, transmission line, device pad, and reference ground together form a complete RF path. Changes in trace width, length, bends, board thickness, or material dielectric constant, DK, can all affect the matching results. If there is insufficient isolation between the input and output, the high power output signal may couple back into the input signal, reducing the product's stability and, in severe cases, even causing self-oscillation. Looking at this PCB, you can see that there are large ground pads and multiple grounding vias near each RF interface. These vias can shorten the return path, reduce parasitic inductance, and improve the continuity between the upper and lower reference designs. Let's go back to the datasheet. Power amplifiers also need to pay attention to heat dissipation and thermal cycling reliability. The R4350B has a Z-axis CTE of 32 ppm per degree Celsius, a TG over 280 degrees Celsius, a decomposition temp of 390 degrees Celsius, and a conductivity of 0.69 watts per meter Kelvin. However, the thermal conductivity of the board material alone can't solve the heat dissipation problem of power devices. In actual designs, you also need to use large copper areas, thermal vias, device bottom pads, metal chassis, and external heat sinks to effectively conduct heat away. In terms of manufacturing, R4350B can use many production processes similar to those for FR-4. Before metallization, it does not require any special treatment and is compatible with both electroless copper and direct metallization processes. R4350B also meets the UL94V0 flammability rating, which is its most important advantage for communication and industrial products that require flame retardant certification. However, via holes, lamination, etching compensation, and impedance controls still need to be re-verified according to the actual stack-up. So to sum up, R4350B is suitable for power amplifiers, not because any single parameter stands out, but because it strikes a balance between its controlled decay, relatively low loss, ease of processing, thermal reliability, and UL94V-0 certification. When designing, special attention should be paid to input and output matching, impedance continuity, channel isolation, ground return, and thermal management structure. If you are designing an R4350B power amplifier PCB, PCBSYNC can assist you with material recommendations, stack-up evaluation, impedance calculation, DFM review, prototyping, and mass production. Scan the QR code in the image and upload your Gerber files to start your inquiry. If you found this content helpful, please like and subscribe. See you in the next episode.